Hello students, I am Dr. Navneet Kaur from Department of Computer Science and Engineering, SIRT College. Today I'll be taking lecture of subject Digital Systems. The topic which I'll discuss in this lecture is Pulse Code Modulation, or we can say PCM system. Now, what is Pulse Code Modulation? Pulse Code Modulation is a method of converting an analog signal into a digital signal. We know that analog signal is the signal in which the amplitude can take any value over a continuous range. That means it can take on an infinite values over the amplitude of the signal. Whereas the digital signal amplitude can take on finite values. So, using pulse code modulation, we can convert an analog signal into a digital signal. The analog signal can be converted into digital signal by sampling and quantizing. Now, first thing, what is sampling? Sampling means that we take samples of the analog signal after a fixed interval of time. That means the time interval between every two samples is fixed. Now, to understand quantization, we will see in detail. Now, what is quantization? Say this is my analog signal for which I have to take the samples and I want to convert this signal into a digital signal. For quantization, I will divide these signals into steps. Now, always remember that the number of steps should always be 2 raised to power n. That means the number of steps can be 2 raised to power 2, that means 4. The number of steps can be 2 raised to power 3, that means 8. It can be 2 raised to power 4, that is 16, 32, and so on. So always remember that the number of steps are always 2 raised to power n. Now here I have taken an example in which I have taken the number of steps as 8. We can see the solid lines. Now if I measure, this is first step, second step, third, fourth, fifth, sixth, seventh, and eighth. So we have divided the whole signal from negative peak value to positive peak value into 8 equal steps. Always remember that we have to take 8 equal steps. Now what we will do, we will form a middle level of all the steps. We can see the dotted lines over here. First is M0, which is the middle level of the first step. Then M1, which is the middle level of the second step. M2, middle level of the third step, and M7, which is the middle level of the eighth step. Now these M0, M1, M2, and M7, all these levels are called quantization levels. Now, for quantization, we have drawn a quantized signal. That means whenever we want to find out the quantized value, we will always see that the signal at particular instant is closer to which sample. Now say, if I'll take a sample here, now we know that if I'll take sample here, this sample will be closer to M0 as compared to M1. That means the level to which it is closest, or we can say nearest, is M0. Then any other level. That means M1 is farther, M2 is again at higher distance, M3 is again at higher distance. That means the value of the sample at this interval is closer to quantization level M0. That means for this sample, the value of the sample will take this level, which is M0. So here we can see I have drawn a quantized signal whenever the samples are from here to here. That means from this value to this value, it will be always nearer to sample M0. So it will always take its value to this sample, which is M0. Now, if I take sample here, now this sample is nearest to this level, which is M1. So this sample will take its value equal to this level M1. That means we are approximated any sample to the nearest quantization level. It is same as like in layman's language, we round off any decimal value to the nearest integer value. That means we can say 2.4 is approximated to 2, 2.3 to 2, whereas 2.7 and 2.8, they are approximated to 3. Likewise, here also, the sample, whenever any sample is nearest to any quantization level, it will take its value equal to that level. Now, here we can see that this signal, which is in the form of a steps, it is known as quantized signal. Now, by using quantization, instead of having multiple amplitude values, we can say that we will have the value of the sample either at M0, M1, M2, M3, M4, M5, M6, or M7. That means any sample will have value among all these 8 values. That means instead of having infinite values, we will have only 8 values of any sample. That means we have quantized our signal and we have approximated any sample to the nearest level, which is your quantized level. Now, this is your quantization. So, here we have converted our signal to the fixed amplitude levels. So, quantization we can say is the process of mapping a large set of input values to a smaller set. Now, the quantization of an analog signal is done by discretizing the signal with a number of quantization levels. Now, here we can see that there is a difference between the original signal and the quantized signal. We can say that there is a difference. This difference is known as quantization error. That means the difference between original signal, which is MT, and quantized signal, which is MQT, is known as quantization error. So here we can reduce the quantization error by taking more number of the steps. Like we can take 16 steps, we can take 32 steps, and we can reduce the quantization error. Now, as I told you that we divide the signal into steps, and the step of the height of each step is given by VH minus VL divided by M. VH is the maximum amplitude of the signal, VL is the minimum amplitude of the signal, and capital M is the number of the steps. In the example which I had discussed, the number of steps were 8. So the quantization step height S will be highest value minus lowest value divided by 8. Now here we can see this is highest value VH, this is minimum value VL. VH minus VL divided by 8 will give you the height of each step. Now, we already know what is sampling and what is quantization. Now we can come to pulse code modulation. So, in pulse code modulation, the amplitude of the analog signal is sampled regularly at uniform interval and each sample is quantized to the nearest value. In pulse code modulation, a message signal is represented by a sequence of coded pulses, which is done by representing the signal in discrete form in both time and amplitude. This is the block diagram of the pulse code modulation. Here we have message signal in the form of an analog signal. First, we give it to sampler. Sampler takes the samples of the signal at fixed interval of time. Say first sample is at 4.7 volt, second sample is 2.14 volt, and third sample is 2.9 volt, and so on. Now, what does the quantizer do? The quantizer rounds off these sample values to the nearest integer value. That means 4.7 is rounded off to 5, 2.1 is rounded off to 2, and 2.9 is to 3. So here, this is your quantized signal. Now, this quantized signal is given to an encoder. Encoder converts these quantized values to 1 and 0. We know that 5 is represented by 101 in binary. So I will draw 1 as positive pulse, 0 as 0 level, and again 1 as positive pulse. So this is 101, which is your 5. Then again we have 2. 2 is represented in the binary form as 0, 1, 0. So 0 is 0 level, 1 is pulse, 0 level is 0. And 3 is represented as 0, 1, 1. So 0 is the 0 level, 1 is pulse, then again 1 is pulse. So this is your binary signal. Now we can see that here we have converted our analog signal into binary signal, which is your digital signal. Now, this is your PCM transmitter. Now, this signal is transmitted across the channel to the receiver. Now, when this binary signal comes to the receiver section, because it has transmitted through the channel, there is spreading of pulses because there is a tendency of the channel to introduce a noise in the signal. Due to noise, the pulses have spread out and they are not in the form of a fresh pulses. Now there is spreading of pulses. Now this quantizer will refresh the pulses and we will again get back the signal in the form of a fresh pulses, which is the same as the signal which we had transmitted. Now, here we have next block as decoder. Decoder is opposite of encoder. Now, encoder had converted the quantized value to binary value. Decoder will convert binary value to quantized value. So 101 will be represented as 5 value, 010 as 2 sample, and 011 as sample of height 3. Now this will be given to holding circuit. Holding circuit is actually consist of resistor and capacitor. And after passing through the resistor and capacitor, the signal will form a continuous signal. That means the capacitor will charge to 5 level, then it will discharge to 2 level. Then again it will charge, then it will discharge, then it will go back to 3rd level. We will get a continuous waveform, and this signal is given to low pass filter. Low pass filter will remove any noise effect. So instead of having here steps, we will get a smooth waveform which is same as the signal which we had taken in the form of a message signal and had transmitted. So whatever we had transmitted, we will get at the receiver. And this whole section will be known as PCM receiver. So here we have seen that analog signal is converted to digital signal. It is transmitted and then again it is converted into analog signal. This is known as PCM system. Now, here we have seen that this is the signal. These are the samples which we had obtained after sampling. Now, these samples are quantized to nearest levels, which are shown in the form of a dotted line. Now, first sample is coded as 100. Second sample is coded as 111. Third sample is coded as 110. And fourth, this sample is coded as 001. So this is how your analog signal is converted into binary signal using pulse code modulation. Now, what are the functions of pulse code modulation? Pulse code modulation is used in many applications like telephone systems, digital audio recording, CD laser disc, voicemail, digital video. It is the commonly used technique in digital communication, and they are the primary building block for advanced communication system. Now, this is all for today's lecture. Thank you.